Our main business objective was to develop a classifier for identification of offensive language in social media. To achieve this, we decided to use Weka. Our data mining objective was to experiment with the different classification algorithms and filters that the software provides. We measured the success of our work by comparing the results of the different classification algorithms according to the F-measure for the offensive class. The data understanding phase began by examining the datasets provided by SemiVal in a plain text editor in order to get a general idea of the data structure. This was followed by exploratory analysis of the data using Python pandas library. Figure 2.1 presents an excerpt from the parsed dataset. The analysis was made on a variable level first. Our findings are summarized in table 2.1. Next, we examined the number of offensive and not offensive tweets contained in the dataset, shown in figure 2.2. Length of tweets was explored too. Found was that over 850 tweets were above the 280 character limit, which raised questions about their authenticity. The analysis identified three data quality issues. Firstly, the dataset was in tab-separated values format, which Weka does not understand. Secondly, the dataset contained data about subtask B and C, which were irrelevant to our project. Lastly, the tweets included user tags, emojis, and hashtags. These data quality issues inform the data preparation process.
I used Python 3 to handle all of our data preparation. I converted the provided data into ARF format and removed irrelevant data columns. At first, I only removed the @user tags from the tweets. This only provided a minor improvement compared to the original tweets. So I realized we needed to clean the data more. I removed all @user tags, punctuation, hashtag symbols, emojis, URLs, and stop words from the tweets. I also reverted contractions to their uncontracted form and changed the letter casing of all tweets to lowercase. This ultimately resulted in a reduced vector space, which led to a significant performance improvement.
The first part is the method we used for modeling. Since most of the classifiers couldn't recognize string attributes, we applied string-to-word vector to convert string attributes to a set of numeric attributes. Then we ran tenfold cross-validation on the training set with classifiers and changed the parameters to get better result. At last, we used F-measure, which considers both recall and precisions, to determine which are the better classifiers. Here are some results we get. The first one is J48 and the second one is a random forest. Both of them are decision trees. As shown in the figure, the results are not that bad, but also not good enough.
And then we try naive Bayesian classifiers. Naive Bayesian classifiers use word frequencies as features to classify documents. First, we try naive Bayesian multinomial with a string-to-word vector and default settings. We can see that the F-measure with respect to the offensive tweets has increased compared to the previous ones. Then we try the same classifier with the following parameters for the filter. By applying ADF transform, the words that appear more often in a tweet or less in the whole dataset weigh more, which helps us to adjust for the fact that some words appear more frequently in general. And by applying the stemmer, we can convert words to their stem for better results. Finally, we apply n-gram tokenizer so that we can classify contiguous sequences. Also, we try naive Bayesian multinomial text classifier, and we can see the result is really similar to the previous one. So we decided to do evaluation on both of them to find the best one.
Now we have trained the models, and the screenshot is the result of using naive Bayesian multinomial on test data. We can see the confusion matrix is clear, and we can get everything we need to evaluate. Normally, there are 4 indicators to evaluate how well the model performed, which are accuracy, precision, recall, and F-measure. Only focus on one part will be lopsided. According to the business understanding, we need to find the most suitable classifier for identifying offensive tweets. So we think the values of recall and precision are the most important. And in the previous part, my teammate gave me 2 models which are both performing well on the training data. And after comparing the results on test data, I found naive Bayesian multinomial is better. And here we are. The values of recall and precision mean using this model on test data, 67.5% offensive tweets are identified correctly in the test data, and 37.5% of not offensive tweets are misclassified into offensive tweets in the prediction dataset. This is the end of our presentation. Thanks for watching. We are Gold Diggers.